Hello, everyone. I'm Felipe, and welcome to our webinar, the second webinar of 2026. And today, I also have Ariella, my colleague here, helping us for this broadcasting. And I also have four special invited this for this webinar: the Javier, Nigel, Qiwei, and Damiano. They are presenting about artificial intelligence and discussing about some topics that they published in a recent paper about how to construct, how to build items based on artificial intelligence. So very welcome and very important to have you here. And thank you so much for you both to accept this invitation for this discussion. As we have been, artificial intelligence is a topic of the moment, is hyping, and every conference that we go, every YouTube video that we watch, so people are talking about artificial intelligence, and we are of course aware of it, and we are trying to use them as the best way for building items and building best testing projects. So thank you so much for being here today. I'll present you very briefly, and if you want to present yourself after, just be my guest. Javier Suárez-Álvarez is an associate professor at Educational Measurement and Psychometrics at University of Massachusetts. Qiwei He is a Provost Distinguished Associate Professor at the Georgetown University and Director of the Measurement in the Data Science Lab, and now is the editor of the International Journal of Testing. Nigel is the founder of the Measure Co AI and Associate Professor at Goldsmith University in London. And Damiano D'Urso is a data science in Habonk and in the independent research applying the data science and psychometric assessment. Thank you so much for being here. I'll leave you with you.
Excellent. Thank you very much, Felipe. And thank you very much to the International Test Commission for inviting us to give this webinar. So today, the goal is to answer the $1 million question of whether AI can build high quality tests. The perspective that we are going to take today, it is really, or our intention is to take a practitioner's perspective from operational testing, how we can navigate this AI age in test development, and how we can really minimize the risk while maximizing the benefits of these technologies. So today with me, as Felipe was introducing, is Qiwei He, Brit, Nigel, and Damiano, which I'm very pleased to be working with them for the past for a little while, trying to figure out how we can identify best practices to really navigate these uncertain times. So I want to spend more time on introductions, just to give the heads up. So this great collaboration with my colleagues resulted in a publication in Psychothema that was released a few weeks ago. So we are going to be talking today about this paper, but if you want to, check more details, feel free to download the paper. I'm giving here the reference and the QR code. I will take opportunity very briefly to promote Psychothema. That is a journal that it has been on the top quartile for quite a few years. It has an impact factor of 3.5. And one of the reasons why I want to promote this journal is because it's open access and probably one of the very few that is free for authors while being open access. So check it out. So the agenda for today, we are going to be talking for no more, hopefully, of 10, 12 minutes each, so that we have enough time for questions at the end. The idea of this session, it is really to give some big picture. I will start with a big picture of how, how to use a psychometric compass when we are using AI in test development. And then I will give the floor to my colleagues that are going to give concrete examples and applications in educational assessment and item generation concretely, and another example on psychological assessment and how to not only develop items, but calibrate those items, estimate pseudo-factor analysis, pseudo-factor loadings and validity evidence based on the internal structure of the test. And then we are going to give like a very brief demo of a pipeline to integrate all of this work. So starting with the psychometric compass, I think this is probably like a cliche, but I really love hiking, so I tend to use this. And I am a psychologist by training, so I tend to use a lot of metaphors and analogies. But the way that I see how we can integrate AI in test validation responsibly, it is pretty much like a hike, no? Like before you start a hike, you really need to make sure that you have the right equipment, that you have the right boots, that you have like a backpack with everything that you need, a map, a weather radar, like a safety rope, a rain jacket. And in this case, the analogy that I am using for the psychometric compass is really the work that, for example, the International Test Commission has been doing for decades now, putting together guidelines, different types of guidelines, not guidelines for translated and adapting instruments, guidelines for technology-based assessments, etc., as well as some of the national standards that many countries are putting together. In this case, I'm using in this slide the ones from the United States that are the standards for educational and psychological testing. I think these psychometric compass, these principles, even if they require some updates to respond to the current needs in AI, they can still serve as a psychometric compass. And in this case, I am intentionally using a compass because in the case of an electricity shutdown, the compass is still going to work. No? And I think that's an important consideration when we are navigating these windy roads. No? And probably the biggest caveat that we are going to face in terms of validity is going to be how these large language models and both generative and representational AI are trained, right? And this is going to define not only the constructs but any output, no, whether that is automated scoring or whether that is automated pattern generation, etc., etc. So how we can address responsibly, no? How we can make like a responsible use of AI in test development and validation. So in this case, I'm going to define. I won't have enough time to go one by one. But I think it's important to have, before we start this hike, in any of the applications of AI that I will describe in a second, but we need to have very clear reliability principles. We need to have clear validity terms like construct relevant variance, construct and other representation. This is pretty much coming from the standards for educational psychological testing, but 5 sources of validity evidence, 6 are going to be very soon in the revised version of the standards that hopefully Brit is going to describe very briefly today. How the revised standards are going to respond to these AI needs. But I highlight and emphasize again 5 sources of validity evidence, right? Like not all sources are going to be equally important depending on the test purpose, but we need to remember that there are 5 sources, very soon 6 sources of validity evidence that we should consider reporting when we develop a test, right? And I feel like, and that I guess we are all guilty of contributing to developing assessments that they have only prioritized internal structure and relation to other variables, which is probably the part that AI can help the most. But we need to remember that there is also content validity. We need to remember that there are response processes, that there are consequential validity, etc., etc. And at the end of the day, we need to put together like a validity argument to defend the uses of the test. No? And I think also very important in the current times is considering fairness and fairness principles and conceptions just beyond differential item function, right? Like how to make sure that the entire test development process follows fairness guidelines. But on the other hand, if we really want to use, like all of these psychometric compass has been the main practice for test development for decades, no? And for hundreds of years almost. But at the same time, if we want to integrate any type of artificial intelligence, whether it's generative AI or representational AI, I think it's important to get familiar with AI literacy, especially when we come from fields like are not necessarily from computer science. No, like being familiar with terms like next word prediction, transformers that became popular since the famous attention lesson unit in 2017, and how the attention scores are improving the prediction of the next word. Tokenization, like how different models provide different tokens, because what we are not really predicting are words, are tokens. The difference between decoders and encoders. Actually, today we are going to have the 2 examples operational examples that we are going to have today in this webinar are going to be an example of each. Different strategies of prompt engineering. My colleagues are going to describe some of these strategies, different temperature, hallucinations, pipelines and workflows, the difference between pre-train and fine-tuning, agentic AI, that I guess this has been defined as we talk, strategies like retrieve, augment, generate. Like, obviously, this AI literacy is going to continue to grow by the minute, but I think being familiar enough before starting using these models, I think is a crucial step to understand the limitations and to understand the potential that they have. No? But one other work that I have been doing with my colleagues, Steve Sirezzi and Sergio Araneda, is we are putting together a chapter that is going to be released in an AI book this summer. And we're trying to think what are the different AI applications, the most popular ones, and how these affect validity. I won't spend too much time in each of them because it will consume all of my time. But let's say, just to give some ideas, and the underlying logic of what I think or what we think is a healthy way to approach this. Sometimes I feel like the field is very polarized between advocates and skeptical, well-funded skepticism about the use of AI in test development. But I think one potential healthy way to approach this is what are the benefits and what are the potential threats, so that we can really put together strategies as the ones that my colleagues are going to describe today, can minimize the risk while maximizing the benefits. But AI applications can be construct identification and development. Obviously, the biggest threat here is going to be that the training models are going to largely influence how the constructs are going to be defined. But at the same time, it can have special potential, special benefits to define new constructs or innovative domains. Automated item generation, that has been probably one of the biggest focus for quite a few years now, can help with cost efficiency, but at the same time can produce low quality items or bias items. I mean, it's not like item writers don't have the same threat, but let's say like here it introduced new threats, because of algorithmic bias. It can allow with innovative types of items, facilitating authenticity and engagement. But as any technology enhanced item may introduce additional barriers and construct relevant variance factors. Item parameter estimation. This is one of the topics that my colleague Nigel and Damiano are going to discuss today. Content alignment, reducing the workload for subject matter experts. Automated scoring. That may improve efficiency and even reduce human bias, because again, like humans also have bias, and it's not necessarily, as a psychologist, I can tell that it's not necessarily easier to correct biases in humans. Personalization, that I think is one of the applications that probably is receiving relatively less attention compared to the other applications, but in my opinion is one that has the biggest potential. It can really allow to personalize the testing experience to diverse test takers. The risk here obviously is misrepresenting or falling in stereotypes of those populations, especially when we are talking about historically minoritized populations. But at the same time, there are strategies that can minimize that influence of the training data. And in general, so I guess that one of the big questions is, how do we validate AI-based assessments? And here I'm going to introduce a little bit of cognitive dissonance, because on the one hand, I think any AI application to assessment is going to remain superficial unless it aligns with core psychometric principles of reliability, validity, and fairness. But at the same time, it's fair to recognize that AI is reshaping how these principles are defined, how they are operationalized, and how they are evaluated. So, and this is part of the discussion that we elaborate more on this chapter that will be released in a few months. But we need to rethink how test validation is changing and influenced by AI. I would say one of the things that is not really changing is the goal of validation, right? Like, it may change the evidence, the method, and the interpretations, but the goal of validation will remain the same in the age of AI. But we need to be able to acknowledge and integrate, not only acknowledge, but integrate all of these new AI practices into the validation frameworks. So I guess one of the biggest threats here, as I mentioned earlier, is going to be how the LLMs, how the large language models are trained on potentially biased training data, how we no longer have just right or wrong responses to an item or endorsement in a Likert scale. We have multimodal inputs, we have process data, we have multidimensional constructs. So which in any case is going to be it can only bring good news from a validity perspective. No, it may make our life as econometricians harder, but from a validity standpoint, it should help to make a more valid interpretation of the scores. And generally, the opaque processes, like how we can improve transparency. So there is, and with these new benefits, there is new risks that we need to figure out and identify. I would say transparency is going to be key. And probably increasing our fairness checks in the work that we are doing. I think that applies to traditional assessments as well. But here, because most of these algorithmic bias are unknown, I think it will require like a bigger scrutiny to make sure that the output is aligned with our intended goals. No, but I will say, just to finish my part and introduce to serve as an introduction to my colleagues. I would say the major challenge of using AI in assessments, I will group them in three. Obviously, this is like an oversimplification and all of these things are interrelated. But I would say in terms of validity, the biggest threat is explainability. So as we all know, the size of these models make it very difficult to understand what is contributing to the prediction. But obviously, explainable AI is going to help in that direction. The accuracy and consistency of the outputs is a threat to reliability, all the hallucinations that the models may have. So model comparison here is going to be crucial, as my colleagues are going to present in a minute. And I would say the biggest threat to fairness is going to be the training data, especially when we are using pre-trained models that have not been filtered out. It may introduce algorithmic bias, but obviously there are strategies, as my colleagues are going to present, in terms of fine-tuning or strategies like retrieve, augment, and generate to potentially minimize all of these algorithmic bias. But now let me give the floor to my colleague Brie, that will talk a little bit about how this applies specifically to educational assessments and item generation. So the floor is yours, Brie.
Yeah, thank you very much for Javier's great presentation, and also introduce this kind of an important idea, especially in assessment, for the education assessment especially. So we can see actually generative AI is a kind of a unavoidable, this kind of a new trend in education assessment. So it's has been emerged as innovative tool, rapidly adopted educational assessment design. And also AI facilitates interactive and authentic assessment formats, including simulations, VR integration, and gamified learning experiences. So automated grading and instant feedback reduce teachers' workloads while enabling personalized learning experiences. At the same time, we also can have this kind of educational chatbots, also known as educational conversation agents, designed to assist the teachers, enhance students' learning process, and evaluate their performance. So basically, I would recommend actually to see this kind of a big framework when we have this kind of educational assessment design. So we can see this is a kind of an over loop. And so because in the loop, we will start from the base training procedure. And in that kind of a case, actually, we will come into this kind of a ensure this kind of training data, the quality, and also refine all this kind of data sets. After we have this kind of base training part, and then we'll come into the AI performance and also make the comparison to make this kind of tool. So in this side, also we can evaluate multiple models for the competencies and also their performance. So for example, just like a teacher, you want to train the students, and AI analyzes your student, and AI agents is your students, and then you can check to see which students actually or which agent actually learned fast, and then give you the input that's most closely to your own. And then definitely we'll come into the validation approach. So in the validation approach, we need to apply a standard evaluation index. It's computer-based program. And also finally, we will come into the sample collection for the AI generated this kind of items. So that is a collected responses samples or have this kind of simulated data involved in. So you can see the whole loop actually after we have this kind of a simulation, and then we will back to the pre-training again. So in this whole loop, basically in our lab, actually we can do the first step and the second step and half of the third step, because we will come into the validation, and only using lab people is not enough. And then we need to have the collaborators from the industry. And the final one, actually, basically, we also need to have the industry to help us to to make this kind of assessment doing. So, I mean, in this whole loop, not only from the lab, we give this kind of a great model from the AI, but actually we also need to have this kind of integration for the collaboration from the industry, from the operation, and also for this final application. So in the next slide, we can see actually if we start to have this kind of case study, for example, we use the NAEP reading passage and use generative AI and to see what will happen when we use the AI. So this is a case study. We retrieved the reading passage from NAEP starting from 1992 until 2020. And we focus on the multiple choice and focus on the reading passages. Because here actually we have the grade 4 and the grade 8 in this study. And so you can basically see the differences when we use the AI and when we have the pre-training part. And the multiple choice question only for here. And then we get the 24 release the passage for grade 4 and 23 release the passage for grade 8. But when we prepare this kind of thing, actually that is a kind of a surprising to us. So in the next slide, you can see actually so the research floor, actually basically we want to do is to say we go for check for all the pre-training data, because the data quality is very important, just like Javier already highlighted there, because we want to check for the pre-training part. And so we come into this kind of a training or validation for our pre-training data. And the other side, actually, we start to prepare our modeling for the AI. So that is two parallel steps. We come into our research flow. From our data collection part, that is pre-training from the NAEP data. At the same time, we'll also prepare our scripts and different prompt engineering and to set up for the AI. And then it's surprising, actually, in the next slides, actually, you can find, actually, we try to see, because we have the grade 4 and the grade 8, these two different groups, and we will focus on their different passages, their difficulty level, right? And we use different readability, this kind of score or metrics to help us to find whether our grade 4 and the grade 8, they are in the different groups, and then we can set up their pre-training and to say, let AI understand what kind of readability level that should be. And basically, we use 10 different readability metrics there. But of course, the metrics, actually, we have tons of the metrics over there. And we select the most significant 10 over there. And then to see whether we have this kind of grade 4 and grade 8 could be seeing this kind of a pre-training quality over here. And surprisingly, in the next slide, we can see, actually, it's interesting to find actually approximately 75% of the passages exhibited very similar as a difficulty level, or the readability score level for grade 4 and grade 8. So that means actually for grade 4 and grade 8, only from their passage perspective, that is hard to distinguish them. Or at least in our sample from the NAEP, we find 75% of the passages actually they're coming into the similar level. So if you can see, we put the figure over here. From the left figure, panel 1, you can find actually, so they have a very big, this kind of a standard deviation for their readability score. I mean, that is across different readability metrics. Here, we just show the 5 over there, but you can see actually for all of them as showing up a relatively bigger deviation, because that is actually for, if we directly put all this kind of grade 4 and grade 8 into the AI, so you can imagine that AI wanted training that, and after the output, all this kind of AI trained passages, you can see actually they still can keep this big variation in between. So for that kind of case, we need to shrink down this kind of pre-training data and to put all this kind of best quality of the data into the kind of way so that we have a very condensed way and to see the readability score for grade 4 and grade 8. So for example, here we use the 4 readability measures over here to help us. And based on all this kind of training over there, the data, and finally we select 6 typically representative passages, and we can use these 6 typically representative passages continue on into the AI training. So when we come into the AI training in the next slide, we can see we use the AI embedded models. So generative AI models, we ask models to generate for grade 4 level readings accessed via APIs and platform. And then we do the same thing for the grade 8. And we train 3 agents over there. So that is a 3 AI agent student for us. One's ChatGPT, one's Met AI, one's a cloud. And also at the same time, we also do the retrieval augmented generation. So we call them RAG. So that is using AI framework that enhances large language model by integrating them with external data sources and allowing them to access and incorporate up-to-date information to generate more accurate and relevant responses. So you can see basically our data come inside, and then the AI agent will start to learn from these 6 typically representative passages. And then they will decide what kind of features there will be, and also to make these kind of features to repeat it here for the training. And finally, they can come into the output. And in the prompt engineering part, in the next slide, we can see. And so for first version, we use a 0 shot. So 0 shot, that is actually general guidance on the grid level complexity. So that is quite a general one. And so we use sentence structures, vocabulary, and word count without giving any examples, because we generally describe to say, as a test developers, you tell AI to say what kind of a readability and what kind of a difficulty level you want to have. For example, like you want to give the grade 4, and in the reading task, whether that's a fiction or non-fiction. So you describe your requirement without giving any examples. So that is a 0 shot. And also we, in the next step, actually we find we also use the second version as a quantified readability standards. And so this is a 1 shot then. So because we give these kind of examples in using the 4 indexes, and with detail give the AI to say how to calculate the indexes given formulas. And also to have this kind of improvement about special specified readability index score targets for 3 to 4.5 for grade 4 and 7.5 to 8 for grade 8. And the required exactly meets the readability standard. So based on this one, actually we find from the prompt engineering, the second one is better than first version. So because we give them more details about that beyond our general description, but also we give this kind of detailed formulas to tell the AI, and also give the examples that we extract out from the NAEP item pool or the passage pool, and to see how these ones can actually link to with the AI. And in the results part, actually, we can see from that for the generated 40 reading tasks, the average of each index is similar between AI-generated reading and original reading. So because we also check to say if we do not have this kind of pre-training quality checking, so if we put inside, we see AI actually give us a non-distinguishable this kind of passages readability score. But after we give this kind of a representative passages into the AI, so we can see AI model makes a good readability. And basically you can see from the average reading level, so we all have this kind of 5.4, 4.43, 4.62, actually for the grade 4, this kind of a level reading ability. And also we find that is from ChatGPT and also consistent with our readability levels, and generated engaging content with a rich vocabulary. And the cloud, this is a simpler vocabulary and less vivid storytelling. And Met AI produce a little bit shorter and more concise readings. So actually that is depend on what kind of your standards actually is to say which kind of way you want to choose, and by different AI agent, because each AI agent have their own characteristics. And so to give you kind of a space or room and to see which one actually that would be better fit in your requirement. And so we also can have this kind of customized GPT, and that it have more interactive and easier to modify than API-based training. So, and also interesting, we find for the fiction and the nonfiction when we have the comparison over here. So basically we have a 20 for each kind of passages. And in the fiction one, so that is object-based, and the nonfiction one is topic-based. And for the AI, actually, we have this kind of training, and we find to say the nonfiction relatively is a higher difficulty compared with the fiction one. So that's his readability score for the nonfiction relatively higher, but nonfiction for the readability score relatively is more stable compared with the fiction one. So based on this kind of a study, actually, we can see for the future direction for this kind of using AI in the generation, even though this is kind of preliminary trial and a kind of a case study to support how this kind of AI can become into the education assessment. But it's important to control the quality for training data, examples, and use identical index to testify the generative results. And also from the framework for the generative AI, it should be set up as the full loop that allows psychometric elements into the process and also to involve into the human and AI together to make the collaboration. And also for the academia lab and also together with our industry. And I'm also honored currently in sitting in the committee for upgrading or revising the standards for educational and psychological testing. So in the committee, actually, we have this kind of a discussion about can AI measure up to our standards. So let's come in to see what kind of a contents actually into these standards. So the ongoing work for the revisions of standards in the next slide we can see, and for that one actually we put as a 22x version because we're trying our best to make it to the public as soon as possible, but actually we don't know what kind of version that will be in the future. So for this new version, actually we will continue to inherit the key things from the 2014 version. So we still have the foundation, operation, and application, these three major sections. And so foundation, actually, just Javier already highlighted to say the validity, reliability, and fairness. That is not changed for the standards. And in the operation, we have test development, test administration, scoring, and documentation. And in the application part, we have the psychological testing, education testing, workforce testing, and credentials, and also program evaluation, policy studies, and accountability. So all these kind of things actually, each chapter will have some elements related to the AI. So let's see what kind of AI actually we want to highlight over here for the AI concept there. So in the next slide, actually, we can see the artificial intelligence actually come into the integration to the standards. So the first one we want to emphasize is to say the integration of AI techniques into standards development represents a forward-looking opportunity to enhance the precision, scalability, and responsiveness. And also the AI can support automated scoring, anomaly detection, adaptive testing, the modeling of latent cognitive process from complex data streams, and the score interpretation and the diagnostic feedback and more. And so definitely in the new standards, we want to include this new evidence and advanced tools from AI for testing. So that would be substantially addressed in the revision part for the standards. And also embedding these facilities, we can find actually this kind of capabilities into the standard framework, not only modernize the assessment practice, but also opens new avenues for the personalized testing and also real-time feedback. But that actually give a kind of core principle for actually for what kind of test framework and the foundation of test validity, reliability, and fairness should remain unchanged, and despite the emergence of AI. So, and actually we also want to highlight or emphasize to say we want to have the human AI collaboration and tools from AI, machine learning, deep learning to facilitate the test process, and a variety of data sources provide further evidence to our foundations, especially on the validity, reliability, and fairness. So that can be integrated toward enrichment in the testing. So I'll give the floor to our next speaker to focus on AI and psychological assessment. Thank you.
Hello, everybody. Thanks so much for the opportunity to talk to you today. I'm going to talk a little bit about AI in psychometric scale development for workforce assessment. And before I do, I just wanted to say, I thought that was a fantastic introduction from Javier on the background and also from Brett talking about AI and educational assessment. And I wrote down three adjectives as they spoke that for me really summarized the situation, and those were innovative, unavoidable, and opaque. And I think that really is where we're at with AI at the moment, and everything that we're trying to do is to try to remove a little bit of that opacity. But as Javier said, these models are so big, the reality is we're not going to understand every little connection that happens in these neural networks. We're going to have to understand it at a little bit higher level of abstraction, and finding that right level of abstraction is what we're actually here to do. And in particular, one area that I focused on with Damiano and colleagues in the International Journal of Testing paper was what we called pseudo-factor analysis. So it's a method for developing psychological scales using AI, using transformers. And there are several of these pipelines around. So there was something in the air, you know, in the kind of early 2020s when different people were experimenting and coming at this from different ways and realizing that actually you can do that. And in workforce assessment, it's really being driven, it is certainly being driven out of industry, you know, it's being driven out of industry. And we're also seeing academic research, but the academic research is tending to lag because of publication times. But one thing we've been working on, as I mentioned, is this pseudo-factor analysis. And why might we use AI in this area for scale development? Well, a few reasons. One, expert item writing is time-consuming and costly. You have to do pilot studies. It can have limited scalability if you're going to use it for a small psychological assessment project rather than large-scale workforce testing. Something else that I would also say is that we've only been working with these transformer models, which I'm using when I define AI. AI is broader than that. You know, there's kind of earlier machine learning kind of versions of AI. There's more rule-based versions of AI, but I'm talking about transformers. So since the Vaswani paper in 2017, we've only been working with that for a little while. So it's not unusual that we don't understand it as well as we understand some of these psychometric scales. So the idea of using it for high stakes constructed response scoring where everybody uses free text, I think we have to be a little more cautious around. But with scale development, we know we've been developing those scales for a long, long time, 100 years, you know, of psychometrics probably and factor analysis. It would be nice if we had a bridge, something that can join together the new machine learning transformer-based approaches to psychometrics and existing psychometrics, and that's what pseudo-factor analysis is. So, Javier, could you advance me? Yeah. So as a kind of pipeline that we talk about, and as I mentioned, there are other pipelines that I've seen. So other people are thinking this, but we first define our construct, and that construct definition is the basis for everything. Everything that we do, and we turn that embedding into a string of numbers with a pre-trained model. So the model's already learned, takes the text as input and turns it into a big long string of numbers. And then we do that for several constructs, and we compare the numbers. We compare the strings of numbers, just like you would compare a normal correlation matrix. And after we do that, we have landed on, well, the construct we're trying to measure is something new, sufficiently different, it's worth us going and trying to measure that. We can actually use generative AI to start generating some of the items. After we generate the items, we can take a new step, actually, relatively new. This used to be done by human and subject matter experts, but we can compare the item string to the construct definition. So we can actually see whether that item is aligned with the construct. And this is a really important point, because what usually happens when we progress from item writing into factor analysis into item response theory, what we see is a shift towards differences in the internal essentially convergent and discriminant validity between what we've already got, but we lose that connection to the external definition. But this step here keeps that step, that link to the internal, to the external definition. It's a really important anchor. After we have that, comparison, what we can do is factor analyze a matrix of cosine similarities. And that's the kind of insight from this little research step that we're doing here. The empirical matrix that we would usually factor analyze after we go and collect response data can be replaced. And I'm saying that very carefully. We can replace it for early item generation, for early signals, to see what the factor structure is likely to be if we were to go and collect that data. We call that pseudo-factor analysis because we're using a semantic matrix rather than an empirical factor matrix. And after that, the really important step that we always emphasize, Damiano and I are emphasizing it absolutely everywhere we talk about it, is that the ultimate criterion that we want is the factor structure of the empirical data, the empirical response data of candidates. But what this does is it gets us there faster. So Javier, please. Work your magic. Yeah, so the first step that I talked about, I say here semantic content validity. I want to say semantic construct validity, but I'm a little more cautious because construct validity has the broader interpretation, of course. But we start off with, we encode a construct label definition pairs with it using a sentence encoder. How do you choose your sentence encoder? Right now, it's a mix between using what other researchers have used, and it seems to work well. We have a look at leaderboards, but right now, aside from that, there is not a really strong basis. Maybe it's being fine-tuned on psychological data, then we might do that. Then you compute cosine similarities. We compute cosine similarities between the strings of text because cosine similarity measures the angle between two vectors. It measures the angle between the vectors, and you can have text descriptions of constructs of different lengths, and it accommodates that nicely. So after we do that, we will visualize the results as a heat map. So here you can see a heat map on the right where we have some constructs that we have used, the example that we had in the paper. And how should you interpret that? Right now, we interpret it similarly to the way we interpret multi-trait, multi-method matrices. And that means we expect correlations between constructs that are more similar to be larger than correlations or cosine similarities between constructs that we expect to be dissimilar. And right now, the interpretation is a relative interpretation. There is no fixed cutoff that we have that says this is acceptable and this is not acceptable, like we have, like we sometimes have for coefficient alpha. Perhaps that will emerge in the future, but right now we don't have that, or that doesn't really exist. And the early work suggests that these semantic structures, the relationships between the definitions, mirrors the relationships between actual responses to scales. So this is a scale level, label level construct. I want to say construct, but I'm being careful. The relations between your proposed constructs. So I'll go to the next slide and I'll talk about the next step in the pipeline. And this is to generate items. And it was not dissimilar to what Britt described in the context of educational testing. So you can give it minimal, you can give the model minimal instructions. And that's sometimes good for more creative item generation. You can let it go, but you can also give it, be more directive. You can give it strong instructions. You can give it definitions. You can give it, you can ask it to, you can tell it what a trait looks like at different levels of the continuum. So not just high and low, but mid, low, mid, and all of this. You can have a blueprint. So this is the zero shot, relatively uncontrolled, good for creative generation. You can do few shot examples where you can give ideal items, which grounds the LLM in context. The point that we make here, and I don't know if other people think this, I think this, all items should ultimately be human reviewed, but this is going to be challenging if you're generating items on the fly, people might have ways that they do that, and some of that more high volume item generation. But for the work that I'm doing in workforce assessment, all items are human reviewed. So thanks, Javier. The next step is to do the semantic item alignment that I talked about here. So sometimes I think this is where in the pipeline of assessment, you lose the connection to what you initially set out to measure, because you only retain the items that you keep, and you factor analyze those. But after you generate the items, you can check the cosine similarity between the item embedding and the construct embedding. And what you want to see is that the items are more similar to their target constructs than they are to other constructs that you don't intend to measure. Here again, close is relative. It's not a fixed threshold. And up until now, this step was really addressed by SME methods rather than being analytically based. I mean, it was maybe I'll say mechanical rather than analytical, because SME-based approaches were still analyzed analytically. So this is semantic item alignment, a method we discuss in the paper, and I will advance one step. And another thing that Britt actually talked about that is seeing a lot of activity in workforce assessment is this notion of retrieval augmented item generation, which we're calling RAIG, R-A-I-G. The idea is you want to get context for the LLM to generate. And just like you give a prompt and it gives context, what this does is it will search a database for relevant content, and it will draw that content from the database, and it will append it to the beginning of the prompt, and then it will carry on with the generation. So that's essentially all the retrieval augmented item generation does. And what we can see from the little plot there is when you use retrieval augmented item generation, you can see stronger cosine similarities between the item embedding and the construct embedding than if you don't. And if you go to psychometrics.ai, you can actually see all of the code where the code all lives there for these experiments that I'm talking about. One thing I want to say is this can be very temperamental. Like all of these AI experiments, my experience is they take some heavy tuning to get to run in the way that you want them to run, to get it to behave in the way that you want to behave. And the key is to have really strong criteria for what you consider acceptable, and then you have to kind of work and iterate with the prompts until it starts to behave like you want it to behave. It will eventually get there, but it takes some work. So that's retrieval augmented item generation. And now I wanted to talk about pseudo factor analysis. So the idea now is we have a whole lot of items. We decided those are acceptable. They appear to align with the construct that we think that they align with. So that's that. But we want to see, how do these relate to one another? Are they sufficiently distinct from one another? And what we would usually do is we would collect a large-ish set of response data. We would turn that response data into a correlation matrix, unless we're using a full information method, and we will reduce that using a method like factor analysis. But here, what we show with pseudo factor analysis is that you can create a cosine similarity matrix of the relationships between the embeddings of all of the different items, and you can factor analyze it, and the factor structure resembles the factor structure you would get if you actually factor analyzed empirical data. And in a couple of papers now, in the original paper where we proposed this with Damiano and colleagues, we had some examples here. Here is the example, the Hexaco model, which is a very prominent personality model. You can see the structure is quite nice, just from the reds there in the loading matrix. In that particular paper, we didn't see congruence. We saw very, very strong correlations and the expected structure emerged, but we didn't see high congruence using Tucker's congruence coefficients. But interestingly, in a subsequent paper that Damiano has just published, and we may be able to share that with you later, he did see the required levels of congruence using Tucker's congruence coefficient, so that was quite good. But another interesting point was the model didn't work as well for Italian, the Italian language, as it worked for the English language. But many people are starting to do this now, and they're using different methods. Pseudo-factor analysis is one of them. It is entering the workflow for psychometric scale development, but will never replace the need for validation on human samples. So that's pseudo-factor analysis. One more thing I wanted to say, I think, is on residuals, exactly. So one challenge when we're analyzing these data are that there is no sample size. So with factor analysis, we have a sample size, don't we? It's the number of participants we have, the number of rows in our data set. When we move into doing pseudo-factor analysis, there was no population. We didn't have a population. We don't have an N. And that creates challenges for model fit, for chi-square tests of model fit, and any fit statistics that's derived from chi-squared or requires an N. So I've seen some people begin to just enter an arbitrarily large sample size there, saying that they think that makes it stable. I don't think this is a good thing to do. This is not a good thing to do because chi-square is so heavily independent. You don't want to be doing that. So I think that one thing that you can do, which is actually came out of a conversation with Damiano and Jerome Vermont, is to use residual-based statistics. And in the paper, Damiano and I show root mean square residual and the common part accounted for as ways that you can check fit for pseudo-factor analysis. And I have one more slide, and I'll hand to my friend Damiano to give a little demo. Yeah, so we showed how to do that with moral foundations for scale calibration. We used sentence encoders to establish semantic construct space. We conducted semantic item alignment to ensure construct relevance. So you really have to do these. A big problem in LLM scale development in any LLM AI psychometric work is prompt compliance. So the LLM will generate all of this. It will always generate, but did it do what you wanted it to do? This alignment checks the prompt compliance. Then when we go to compare, we compare multiple prompt engineering strategies. We will move into embedding-based factor analysis, and we do iterative refinement for item selection in the same way that we do for if we had the data. And then after we have done that, we can take fewer items to trial. We got to trial faster, so there's a good economic benefit to it. We can use some, sample size free exploratory techniques to evaluate model fit. So thanks for the opportunity to talk to you about that. Over to you, Damiano.
Yes, thanks, Nigel. And first, let me say that I'm very, of course, glad to be involved in this work with all these fantastic colleagues that have presented before me and to be invited for this talk. I think in the interest of time, I won't propose my 3 words for AI like Nigel did, but I will try to move to a demo where I will show a little application that we have built that can be used and try to mimic a little bit the pipeline that we discuss in the paper. And the application is open source, so you can all freely use it. So I'm going to now share my screen so you can see the application directly. So the application is hosted on Hugging Face, and this is a link. I think it will be added to the YouTube chat, but it's called Validata. And the idea is that it contains at this point 3 aspects, and they are basically item generation, item validation, and item refinement. And the generation part, which I'm going to start sharing, there's, as always, there should be a big disclaimer, like Nigel already mentioned. And the idea is that in the item generation, you provide an initial, basically, the construct that you would like to measure. And yeah, I'm quickly checking. Yeah, so the construct that you would like to measure. And here I'm just going to reuse what we have, which is like growth mindset and test anxiety. Okay, yeah. So I think there was a problem with the sharing, but so here's the agentic psychometric item generator. You just provide the construct you want to measure. So we have these two. And then you start adding constraints. And constraints could be things that already Nigel mentioned, but also Brit, like what population you have in mind, what context, all sort of additional information. And what you're going to get first is that the AI will think about 2 follow-up questions for this assessment. So in this case, is what is the age group or educational level? Yeah, I'm just going to say, for instance, 18 to 60. But you don't have to respond to these questions. They're just optional. And some specific constraints, right? So are you looking for positively framed items, negatively framed, etc.? And of course, these are some constraints that are proposed as a follow-up, but you can add already your constraints in this box here. And the next step is that you provide some settings for the generation. So for instance, the minimum number of items, the maximum number of items per construct, and the total cap. So how many items do you want to generate? I'm just going to try to keep it small for the generation from now, but what's going to happen now is that in the first step, there will be what Nigel already described as retrieval augmented item generation, where we search in a database of existing items in psychological papers. At this point, the database that the app uses contains only a couple thousand items, but soon I hope to add a couple 100,000 of items because I found a recently interesting database. So that would, of course, could ground a bit more the generation step. And that would help, of course, in creating a bit more, let's say, informed items. And at this point, the step is kind of hardly coded, so it cannot be skipped. But hopefully in the future, this could be done. And then there are some initial quality checks that are done. For instance, if the items flagged, if they are too long, more than 20 words, and some double-barreled quality checks. So, for instance, item that contains an end, because they could become not uniquely, and they could become not very clear because they would, for instance, refer to the different concepts in the items. Then you get some general scale metadata, and you see the generated items here. So, for instance, this was about, we said, growth mindset, right? So that's what we used. And the first item is, I enjoy tackling difficult tasks that help me learn. And you would see what kind of facets this would refer to, the polarity of the items, and what is it inspired by. Sometimes there is an issue with the links. And it also explains the rationale behind this item. And then you have item 2, for instance, which refers to self-efficacy, and I believe that my abilities can improve with effort. And it indicates where it is inspired. You cannot directly click on the link, but if you just copy, this is a DOI, if you just copy it, you'll be able to refer back to the paper where this item was, that the source items that is used to inspire the generation is from. And then, you just get this list, and you can just look at different, all of them, and decide what you're going to use. Probably at the beginning, you're going to generate much more, and you can download this file in 2 different versions, a JSON or a CSV. But let's assume now you would download this as a CSV, and now what you want to do is that after you have, for instance, just used these 20 items or modified some of them, others, you want to start moving into the validation step. And here, what you can do is basically, this is what already Nigel discussed in the alignment and pseudo-factor analysis, and you can approach this 2 different ways. You can either upload the file with the constructs and item text, or you can just start imputing the text manually. I can say, for instance, extra version, and do the same for the items. But for this example, I'm just going to use a pre-made file that we already generated. So this is just similar to before. These are just the items for growth mindset and test anxiety. And the first thing that you would see by just using these initial items, you will get some pseudo reliability indicators. They are built on construct item similarity. So that's just the average cosine and the internal consistency. So we use that cosine similarity matrix that Nigel discussed. And then we use basically that as a base for calculating alpha and omega. You will get some initial alignment parameter. So basically, this is just similarity between that item text and the growth mindset construct definition. And the initial factor loading, so using pseudo factor analysis. And as you can see already here, the generation was kind of positive based on this initial assessment of the factor analysis. But you can see that two factors are quite nicely divided, with the exception of some items. So that's, and one of them is of course referring more to the growth mindset, and the others to test anxiety. And you can download all of these as CSV. And you can also download the item correlations, which are not really nicely looking here, as CSV. And for the last step, what you normally do also in, well, test refinement is that you want to, for instance, to reduce the number of items you have generated. Ideally, like we already said, all my colleagues before, you would do it with real samples, but in the first piloting phase, perhaps you generate 300 items. It's going to be very costly to assess all of them, so you want to refine some of them. So you can just reuse the cosine similarity matrix from the step before as an input here, and you can add some parameters. So here we just have two factors because we have two constructs, the minimum number of items per factor, the salient loading, I'm just going to put it a bit higher because we want to select, for instance, best items, and the minimum cross-loading. Again, this is all based on the pseudo-factor analysis results. This was run on a refinement, and you would see that from the 20 that we initially generated, something like that, we will reduce it to a couple of them. And the rules are described here. I'm not going to go through them in the interest of time, and because I would like to give some time to Javier to finish and to address the audience questions. But this is basically what you can do with this Validator app, which is continuously in involvement. And if you have ideas, please, I'm very happy to hear about feedback and suggestions, etc. And now I'll stop sharing my screen, and I will give the floor back to Javier.
Thank you very much. They were all of them like fantastic presentations. Thank you, Damiano, Nigel, and Brit, for showcasing how we can navigate the challenges of AI applications in test development. So, Felipe, I don't know if we have a chance to reserve my screen. I just have like a few concluding remarks, and then we can address questions from the audience. So I think one of the things that I think is worth considering is that despite, I mean, as you can imagine, and as my colleagues showcased, like how we implement from an operational perspective all of these new models is going to change, right? But one thing that I won't spend much time in the interest of time, but that we describe in the paper is like there is some common underlying steps, right? Like in the same way that Nigel was describing for the item generation and calibration of psychological assessments aligns to some extent to the way that NAEP and the reading assessment generation that Brit was describing, right? Like there is these intermediate steps that to some extent are parallel or resemble some of the steps that we always follow in developing traditional assessments, but now with these intermediate steps of model comparison for reliability, of standardizing validation procedures, verifying, like all of these intermediate steps, right? So I would say just as a concluding remark that as AI continues to evolve, like this webinar, if we do it every month or every year, it's gonna change. But the validation logic, this moral and psychometric and ethical compass in how to navigate, how to address the validity threats, probably the validity threats are going to change over time as well. But like I think the final message that we want to send that we all presenters agree is that the validation logic will stay the same, no? And just to remind us that we are not longer just validating test uses and interpretations, but we are validating entire AI assessment pipelines, no? And every different step in the pipeline may introduce new biases, but at the end of the day, the real challenge is not really AI, but how humans decide to use it, no? And we do strongly believe that if used responsibly, following principles of reliability, validity, and fairness in every step of the process, AI has the potential to really build better assessments that humans can do on their own. So thank you very much. And I think now we can give the floor for some questions. Felipe, the floor is yours.
Yeah, can you hear me?
Yes.
Yeah, thank you so much, Javier, Damiano, Britt, and Nigel, for your outstanding presentations. It's for sure it's very recent publications and very recent topic as well, and it's very important for test development, test validation, and we are very glad to have you here on this webinar. So we still have like time for one or two questions, and I'll put one of those questions here. Yeah. I would say, since you'll be my guest to answer, who wanna decide to answer. Since pre-trained models are mostly trained on English, what methodological safeguards are necessary to prevent this bias from infecting test designs for cultural or linguistic distinct populations, in terms of bias that might embedded in the models itself, right? So can you answer one of these questions?
Sure, I can chime in very quickly, but then I want to really give the floor to Damiano because he just published a paper a few weeks ago, I think, answering some of these questions. The only thing that I wanted to add before giving the floor to Damiano is that, well, some of these concerns doesn't really apply to AI, no? Like humans we are known to be biased. So I think some of the fairness research, and for example, all of the line of research in cultural responsive assessment and co-design can really help inform and can really help address some of these issues once we are working with AI, right? Like obviously, as some of my colleagues mentioned as well, like the training data, I mean, most of these LLMs have been trained on mostly Anglo-Saxon sources, so that may introduce some algorithmic bias. So I think there are different ways that this can be addressed, and I think some of the ways were discussed today, like fine-tuning the models using this RAG strategy. Some of the work that we are doing here at UMass is based on creating students' avatars that better represent the lived experiences of the target audience and the test takers, and trying to build that into the workflow so that it better operationalizes and mitigates those potential biases. But yeah, this is one of the biggest risks, and luckily there are a lot of efforts in trying to minimize this. But let me make sure that Damiano, do you want to add anything else?
Sure. I mean, I think you already mentioned most of the things that I would also suggest. I think in our paper, indeed, what we saw is that you cannot just blindly use this pre-trained model for item validation, right? And I think it also came out from all our the talk today that this is not a replacement, right? We just want to speed up piloting processes, but at the end of the day, the tests are built for humans, and the validation, especially with concerns to measurement invariance, which is here perhaps one of the aspects that is mentioned, so cultural, linguistic, differential item functioning, it remains with human testing, and without that we cannot really. So I would argue against everybody saying let's just develop a test with AI and say that it's fair and culturally okay. So it should always keep humans and use them to assess the actual validity of the test.
Yes, if you allow me to make one comment about this one as well. I have an experience using ChatGPT and Dale for item generation for images, and I'm working on assessing prestige and on vocational interests using pictures, and ask it freely to the ChatGPT generate images for high prestige and low prestige situations according to different kinds of occupations. And surprisingly, at the end of like a 50 or 60 images, all the images of high prestige are made by white men, no blacks, no women, totally biased. So one thing that is try to solve this problem is to create an avatar for the all items and using the avatar for all the items, so we can reduce the bias embedded into the model. Yeah.
I absolutely agree. And I think it's one of the biggest topics that is discussed in these days, how to unlearn patterns that these models have learned in the data and to try to move away from those biases, right? Yeah.
Thank you for your presentations. We have another question. So future prospects of test developer, what skills they need to learn to stay relevant in the area of AI? Do we need to rebuild our profession and industry?
Maybe just briefly, I can start by responding, and then I think all of us probably have an opinion on this. I think the skills are not going to change, right? Javier already mentioned at the beginning, and also Brit, the compass remains the same. The principles remains the same. We add some, but it's not that it's going to all of a sudden become less relevant to think about how to define a construct, how to evaluate an item, how to select if an item is right or is not, etc. Right? It's more about use. I think the risk is not in the skills, but it's in the in junior positions. So perhaps some of the work that was done perhaps in junior test developers, which is like generate items, etc., is now going to be heavily influenced by the fact that you have a machine that does it for you. And are those people still going to be learning how to generate items, or are we going to replace these young test developers, right? So down the pipeline, we have to think what's going to happen to young people entering this kind of industry.
Yeah, I would like to supplement something here, because I do think this is a very good question. For the test developer, I think basically could have three kind of elements inside. So one kind of test developer, they will focus on the content. So what kind of content or subject this kind of a specialist come into development. And the second part that will be psychometricians, because they will understand if you design this kind of item, so what kind of potential methodology or research model that we can use. And so the third part actually could be kind of a high-tech part. So for example, AI agent could be one of the collaborator inside for the test development. Currently actually in our university, we'll also have the new courses named AI measurement with AI, adaptive measurement with AI. So actually we add into this kind of element of the generative AI ultimate scoring. But I do think just like Damiano and Javier already mentioned, to say the principle of the test will not be changed. For example, when we do have this kind of a standards revision for the test development chapter, we emphasize to say the principle we have the test development will not be changed. But of course, we will have this kind of more and more this kind of advanced tools to help us to do that. So I don't think actually we will stay relevant in this era of AI, but actually we will learn some more techniques actually to help us to make this kind of test developer, this kind of a function actually more rigorous and more agile over there. Yeah.
Nigel, do you want to comment or?
It's a similar. I have a similar view. I think just the ability to think analytically, to be able to evaluate evidence and decide whether this is acceptable evidence, that it's working in the way it is against the standards that Brit's, just given us the update on. That kind of analytical mindset, I think, is necessary. And yeah, I think there will be specialization. So some people will be the content experts, some people will be the AI experts. But I think if I was a graduate learning it now, yeah, I would see these as new tools to do things that we already know how to do. And things like multi-trait, multi-method, CFA, the IRT models, all of this, I would learn to fit it all. and then just see how it kind of connects to this new generation, this new way of measuring.
Yeah, I totally agree. I will just add, in addition to everything that my colleague said, that I fully agree, is collaboration, right? Like, I feel like this has not really changed, like test development, like, to put an example, like PISA, no? Like, it takes, like, I mean, if you look at acknowledgements of PISA, there are quite a few hundred people behind putting the test every 3 years. And that has always been the case before computer adaptive testing, before AI. Like, it takes a lot of people to develop a test, right? I would say, like, one of the biggest risks now is because, especially, I mean, whether you are using programming or you're using interface, like, I feel like now anyone in an afternoon with ChatGPT can make you believe that you are a content expert, a psychometrician, a developer, like you can do all roles. I think the important thing is just not to fall in the trap of self-perceiving yourself as an expert on everything, and just talk to other colleagues, just collaborate with other people and make like a multidisciplinary team where you can address, because that's the thing. I don't think that never was the case, but even now, even less. Like, a single person cannot address all potential issues related to reliability, validity, and fairness in test development, right? Like, that has never been the case, but it's not different now, if not worse, no?
Okay, yeah, thank you so much for your outstanding presentation. As I mentioned before, it's like a very dated topic, a very important topic for the community of testing, and I'm very glad to have you both here on this presentation. I guess it's our second, third, or fourth webinar dedicated for artificial intelligence, and we cover in different topics, different technicals, different issues, different problems, different technologies. But at the end, we have the same results, that the artificial intelligence still need like human supervision, and it's still very important to to have those skills to use artificial intelligence, but also have a human at the background validating all the decisions and items that we build and validate that we make of those items. So thank you so much for you being here today, and Ariella as well for helping us on this webinar too. And see you in the next webinar next month. Thank you so much.
Thank you, Felipe. Thank you, Ariella.
Thank you all. Bye-bye.
Thank you. Thank you.
Thank you all.